Hello students, welcome back to my YouTube channel. Today I am going to solve one of the very interesting problem. The question number is 82. Question number is 82. CSIR Net Mathematical Science. Students, first understand the question and the option, then we will solve. In the question, they have given let f is a function from real number to real number, that is domain is R and codomain is also R, be a continuous function such that f of x equals to 0 for all x less than or equal to 0 and for all x greater than or equal to 1. Define capital F of x equals to summation n equal to minus infinity to plus infinity f of x plus n comma x belongs to R. Which of the following statements are true? Option A, capital F is bounded. Option B, capital F is continuous on R. Option C, capital F is uniformly continuous on R. Option D, capital F is not uniformly continuous on R. The concept behind this problem is very simple. There are two types of functions. One is small f and another one is capital F. For small f function, they have given certain information. The small f function is continuous and this domain is R and codomain is also R, and they have given some hint. F of x equal to 0 for all x less than or equal to 0 and for all x greater than or equal to 1. Using this information, you have to construct capital F of x, because we don't know what is capital F of x, but capital F of x is constructed using small f of x. Because you can see the options, all the options they are asked in terms of capital F of x. The trick is very simple. Using whatever the information given for small f, use that information and construct capital F of x. Then easily you can solve this problem. Now step 1, given whatever in the question, just write it. Given f is a function from R to R, be a continuous function such that f of x equals to 0 for all x less than or equal to 0 and for all x greater than or equal to 1. Therefore, this is 1, this is 2, this is 3 dash dash so on, this is minus 1, minus 2, minus 3 dash dash so on. F of x equal to 0 for all x less than or equal to 0 means this portion function value is 0, and for all x greater than or equal to 1, for this portion the function value is also 0. But we don't know, the function may be like this, the function may like this, the function may be like this, the function may like this, because they have clearly mentioned that small f function is continuous. If it is a continuous, means some graph exists. Again, I will draw the graph. Zero, 1, 2, 3 dash dash so on, minus 1, minus 2, minus 3 dash dash so on. x less than or equal to 0, the function value is 0. X greater than or equal to 1, the function value is 0. But the function f is continuous. We don't know what type of graph from 0 to 1. It may like this, it may like this, it may like this. Another information they have given. Capital F of x equal to summation n equal to minus infinity to plus infinity. F of x plus n, x belongs to the real number. This, please listen carefully. Capital F of x equal to summation minus infinity to plus infinity. It is very difficult to write down all the term from minus infinity to plus infinity. It is a very difficult, because how can you write the infinity terms? For my convenience, I will write little bit terms. That is, f of x equals to dash dash so on plus f of x minus 3 plus f of x minus 2, f of x minus 1 plus f of x plus f of x plus dash dash. Call this is as equation number 1. Now, can we guess the graph of capital F? At x equals to 0, what is capital F of x? Now, put x equal to 0 in equation 1. Put x equal to 0 in equation 1 and calculate f of x value. Okay, please you do it, because time is also very important. I have to complete within a time this problem. So please do the calculation for your practice. You will get f of 0 equal to 0. After that, put x equal to 1 in equation 1. Then you will get f of 1 equal to 0. Put x equal to 2, 3 and so on. You will get f of value, and you can see here at x equal to minus 1, f of minus 1 is 0. At x equal to minus 2, f of minus 2 equal to 0, dash dash so on. Then we came to know that at all integers x, f of x equal to 0. Capital F of x equal to 0. Capital F of x equals to 0. Now we will calculate at fractional value. Let x equal to 0.5, put in equation 1 and calculate. You got this. Put x equal to 0.9 in the equation 1, you got f of 0.9 equal to small f of 0.9. For all x belongs to 0, 1, you got some relation. Capital F of x equals to small f of x. Again, let x equals to 1.5, put in equation 1, you got capital F of 1.5 equal to small f of 0.5. Put x equal to 1.9 in equation 1, f of 1.9 equal to small f of 0.9. So for all x belongs to the open interval 1, 2, capital F of x equals to f of x minus 1. Let x equals to 2.5, capital F, this put in equation 1, f of 2.5, small f of 0.5. For all x belongs to the open interval 2, 3, we got f of x equal to f of x minus 2. Similarly for other values. Now we will draw the graph of capital F of x. Dash dash so on, minus 1, minus 2, minus 3, dash dash so on. At this, the value is 0. Using the condition, at this term also the value is 0. using the condition, but 0 to 1 we don't know, but we know the function is continuous. Let us I am assume the graph of this continuous function may be like this. Just let us I am assuming this one. Now I am trying to construct capital F of x graph. See here, in the capital F of x equals to small f of x in the interval 0 to 1. In the interval 0 to 1. Therefore, the same graph you will get. Here, this is small f graph and this is capital F graph. Now, put x equal to 1.1. Here, what is the general relation? For 1 to 2, put x equal to 1.1, that is f of 1.1 equal to f of 1.1 minus 1, that is equal to 0.1. That is f of 1.1 equal to small f of 0.1. The meaning of this one, see, f of 0.1 graph we know. F of 0.1, example, this is 0.1. This is the graph. At 1.1 also the same, 1.1 also the same. Now calculate for 1.2, f of 1.2 equal to small f of 1.2 minus 1, that is 0.2. Again, for f of 0.2, this will be the value of the function. Again, for 1.2, the same height you will get. Using this, you will get this type of graph. Again, for 2 to 3, if you using this condition, because small f of value we know, using that, if we draw the capital F of x value, you will get like this for negative term. If you assume in this way, let us another option. If you assume in this way graph, then capital F of x graph will be so roughly I have drawn. Using this value, you can draw neatly, no problem, because I have to solve within time. That's all I have drawn the roughly. But please, I think you understood this concept. Now coming for the option. This is a bounded set. In option 1, it is a bounded set. Yes, this is a bounded set. Capital F is a bounded set. If you choose in this way, the graph, it will be repeated in this way only. Second option, capital F is uniformly continuous. Yes, one standard theorem is there. If a function f is continuous in the closed and bounded interval, then it is uniformly continuous. This is also correct option. Now we will check the option. Coming to the option. Capital F is bounded. Yes. Capital F is continuous. Yes, it is continuous. Capital F is uniformly continuous. It is uniformly continuous. Capital F is not uniformly continuous. This is wrong. So students, what we have done? They have given the information of a small function. Using that, we have constructed, or we have drawn the capital F function, and from the option we have selected the answer. This is a very simple trick, because capital F of x, they have given summation minus infinity to plus infinity. To write down all the terms, it is very difficult. So I have chosen selected terms. Call this as an equation 1. After that, simple calculation is there. You can practice it, or you can do in any paper or computer also you can use. You can get the answer. I hope students you have understood this problem. Next time I will solve some one interesting problem. Thank you friends.